All right, we're working on activity 2 and 3. We're finishing up lesson 1 in module 2, topic 3. We're still working within the same context where we're purchasing shirts and then selling shirts to raise money for a fundraiser. But let's look at the situation slightly altered for activity 2. It says, after the initial analysis, the PTO calls the company that produces the shirts to negotiate. The company agrees to discount the design fee to $80 while keeping the cost of $4 per shirt. So let's highlight that there. So this is all in terms of costs. 80 for the setup fee. So in the last lesson it was $160, so they negotiated down to $80, half that price. And then from there, right, something that represents what we're selling. The last sentence, the PTO asks you to analyze the profit potential with the new costs at a new selling price of $12 per shirt. Okay, so selling price. So in the last lesson, we were selling the shirts. The PTO was selling the shirts for $8. Now they're making it slightly more expensive. They think people will still purchase the shirts, and this will help increase their profit margins. If you remember in the last lesson, we had to purchase 40 shirts for our break-even point. Okay. All right, number 1. Write an equation that represents the cost in terms of dollars for the long sleeve t-shirts. So what I highlighted in red here, that is the equation. So the equation in slope-intercept form, y equal to mx plus b, right? B is where we begin, that's $80. And m is how much we move or how much we're increasing, that's $4 per shirt. So y equal to 4x plus 80. And then y is the total money that we're making from that. And then for number 2, in terms of selling, so write an equation that represents the organization's income from selling the long sleeve t-shirts. So that is y equal to, if you remember from the last one, when we sold it for $8, is y equal to 8x. This one, we're selling it for $12, so it's y equal to 12x. Okay. And then now we're going to complete this table using these two equations here. So let's write the expression. So the expression for the unit of long sleeve t-shirts, we're just going to put any variable. We typically put x. Okay. The cost, right? The cost for us is going to be 4x plus 80. We'll get to that soon, but let's also write in what our income is. Our income is y equal to 12x, or we'll just put in 12x. Okay. We're going to plug in for these varying costs 0 shirts, 5 shirts, 10 shirts, and so on. Right, so we're always plug into x. So for the first one, we're going to plug into x, multiply by 4, then add 80. We're going to do that all mentally for now. So for 0, 0 times 4 is 0, plus 80. 0 plus 80 is 80. 5. 5 times 4 is 20. 20 plus 80, 100. 10. Right, 4 times 10 is 40, plus 80. 40 plus 80 is 120. And then we make a big jump here. We go to 35. I'm going to give you the answer for that. Right, 4 times 35, that is 140, plus 80, that is 220. 2 more, 50. 50 times 4, well, 5 times 4 is 20, so 50 times 4 should be 200. 200 plus 80 is 280. And the last one times 100, this will give us a cost of 480. Okay. Now for this other one, for income, we're just going to multiply it by 12. Okay. Maybe we don't know our times tables by 12, but I think we should at least get a couple of these here. 0 times 12 is 0. 5 times 12 is 60. 10 times 12, 120. 35 times 12, you can use a calculator for that, but that is 420. Next one is 600. Now the last one is 1200 or 1200. Okay. All right, so our profit, if you remember from the last lesson, it is the income minus the cost. So it's this minus this second column. Third column minus second column. And so that's represented as 12x minus the cost, which is 4x plus 80. And you could plug in there, but I already have these values, so let's just subtract it from there. the first one, 0 minus 80. If we don't have any shirts, we're in debt $80, so negative 80. If we only sell 5 shirts, that is 60 minus 100, which is negative 40. Okay, if we have 10 shirts, 120 minus 120 is 0. That's going to be an important observation there. I'll give you the rest. Next one is 200. Second to last is 320. And last one is a profit of $720 when we sell 100 shirts. Okay, so we're going to move on to, we're going to use that information to go on to the next page to now graph this. I think last time we did cost first, and we're going to highlight cost in terms of, well, in red here. So our first ordered pair is 0, 80. Okay, so let's graph that. So now move on to the next page on 313, 0, 80 right here. Okay, so we're completing number 4. Next one, we go to 5 shirts. 5 shirts is $100 in terms of costs. So 5 right here, 100. Right, this is actually 100 right here, right? Because if we go from 80 to 20, that's 40 units away. Half of that is 20 units away, and 80 plus 20 is 100. So this is 100. So where these two cross, right here to here. All right, let's go to the next one, which is for 10 shirts, 10 and 120. So 10 here, 120 here. Looks like it's right there. And then we make a big jump to 35. 35 to 220. 35 here, 220 right here. Okay, just do our best to try to line them up. Okay, and we'll go one more. We'll go to 50 and 280. So 50, 280 right here. Let's see where they join. Okay, and let's go ahead and join all these points one more time, right? Just like the last lesson, you can use a straight edge if you want to borrow one. This represents cost, and this is the equation, y equal to 4x plus 80. Okay. Now let's go ahead and graph what we have from the other one. We'll graph this in blue. So I'm going to get rid of this and this. We're going to use the first column and the third column. All right. So next one we're going to go to is right here, which is actually the origin, 0, 0. 0, 0 is at the origin. All right, next one is 5 and 100. Okay, let's see where 100 is. Oh, whoops, not that one. I'm on the wrong one. This is 5, 60. Okay, so 5, 60, that's right here, and 60 is right here. Okay, so we have this point here. Next one, gotta make sure I'm looking in the right place. 10 and 120. 10, we already highlighted here. 120 is right here. So where they join, it's actually where this red point is at. So let me connect us for now. Okay, let's do a couple more. We'll do 35 and 420. So 35, 420 is the last space on here. Okay, so 35, 420. Pretty much I just go to 35 all the way up. And let me connect that. It should be still on the same straight line. Yep, and we'll draw an arrowhead to know that we're finished here. We have some more points, but we're going to go off the graph. Okay, all right. So, and then let's go ahead and write out. This is our income. And the equation for this was y equal to, not 8x, that was the last one, 12x. Okay. All right. Now, if you remember from the last lesson, we were talking about break-even points, but let's look at A for now. Determine the number of long sleeve t-shirts for which the cost is greater than the income. So cost is in red, income is in blue. So where in this graph is red above blue? So that is, if we look right here to the left of this, everything to the left of this, this is where red is above blue, right? You see red right here and blue right here. Okay, so that is that's at 10 shirts and everything left of 10 shirts. So how do we write that out? Okay, so everything left of 10 shirts is the cost is greater than the income when the PTO sells, or everything left of 10 sells fewer than 10 shirts. 10 long sleeve t-shirts. Okay. And then for B, determine the number of long sleeve t-shirts for which the income is greater than the cost. So income is in blue. Everything that is right of this green line, that's where blue is above red. So that means it costs more, or we have more money. So the income, how much money we're receiving, is greater than how much money that we're using or spending. Okay, so that is when the PTO, parent teacher organization, sells more than 10 shirts. All right, and determine when the cost is equal for C. The cost is equal to the income when the PTO sells exactly 10 shirts. All right, so like at least for Gibson, right, there's varying spirit shirts for, right, house shirts and clubs and leadership and all those things, right? Those different advisors and groups have to figure out, right, how many shirts are we going to purchase in anticipation of how many students or teachers or parents are going to be purchasing those shirts. Otherwise, they could be losing money, right? So the cost and income is, or we'll say R, so that is, we go to 10, go up to here, that is $120. Okay, so we're spending $120 to purchase the 10 shirts, and also if we sell those exact same 10 shirts, we'll be receiving $120. So the cost is equal to the income when those two graphs intersect, the red and the blue line. But we're also going to verify this, right? Verify this algebraically by substituting the values of the variables and evaluating. So let's write the first equation, y equal to 4x plus 80. And then our solution is actually using these two values here. It's 10 shirts, comma, $120. So we're going to plug that in for x and y. So instead of y equal to, we'll have 120 equal to. Instead of 4x, it'll be 4 times 10. And we'll keep this plus 80. Okay, so same thing that we did in activity 1. Right, simplify using order of operations. 4 times 10 is 40. And 40 plus 80 is 120. All right, so we put a check mark there. This satisfies the first equation. This equation represents its cost. Will this satisfy the other equation? Y equal to 12x, which is in terms of the money that the shirts that we're selling and how much money we receive from that. So instead of y equal to, we'll have 120 equal to. Instead of 12x, we'll have 12 times 10. And 12 times 10, right, when you multiply by 10, you just add a 0 to whatever you're multiplying by. So it's 120 equal to 120. That satisfies the equation there. So this is a value that is a solution, right, to both equations. Okay, let's finish analyzing activity 2, and then we'll get to activity 3 and call it there. What is the break-even point for producing and selling these long sleeve t-shirts, right? We already put it. It is 10, 120, 10 shirts. What are the costs and income at the break-even point? Where break-even point is when you're no longer negative and you become positive. Right, so the cost and income is $120 at the break-even point. Let's put PT. What is the profit from the t-shirts at the break-even point? Right, that is $0. We don't make a profit. But we're no longer in debt. We're no longer negative. What do the coordinates of the point of intersection mean in terms of the fundraiser? So the point of intersection (10,120) means that the PTO, right? They purchase, or we'll say the PTO buys 10 shirts. It costs $120, and we sell all the long sleeve shirts. So let's say, and the income is also $120. Okay, this means that there's no profit and the fundraiser breaks even. And then number 10, right? State the number of long sleeve t-shirts the PTO must sell to make a positive profit, right? If 10 t-shirts doesn't give us a profit, $0, or we just gotta sell one more than 10 shirts, right? So we'll just say one more than, it's whatever your answer is, your break even. It's always one more than it. One more than 10 shirts. So simply, we'll just say 11 shirts. Okay. All right, good there. We're now going to go in a slightly different context and try to figure out break-even points for equations that might not be in slope-intercept form, so in standard form. And that's what we're going to see here on activity 3. So actually, this is our last page, page 315, and then we'll have our assignment. So it says determining a point of intersection to solve a problem. Okay, so it says in the previous activities, the point of intersection represented a break-even point. In this activity, you will use a pair of linear equations to represent a problem situation and interpret the point of intersection in terms of the problem context. Okay, so we're going to have to do some highlighting here. Let's put blue. Okay, so it looks like we got some pizza places here. So it says Serena orders lunch from Tony's Pizza Parlor. John told her that he paid $34 for two 16-inch pizzas and 2 drinks when he ordered from Tony's last week. Okay, so this is what John is saying. $34, 2 16-inch pizzas and 2 drinks. And then this other person, Jody, told Serena that she ordered one 16-inch pizza and 3 drinks, and it cost $23. So one 16-inch pizza, 3 drinks, cost $23. Okay, right. So it's more expensive for John because he purchased 2 pizzas and 2 drinks. So number 1, write 2 equations to represent the two statements that Serena hears. Now in this case, there is no slope-intercept form because there's nowhere where you begin. You don't pay like a startup fee or anything like that. But what we do have is we have 2 rates. We have a cost for pizza. We have a cost for dollars. When we have something like this, you write an equation in standard form. AX plus BY equal to C. And C represents the total of this left side. Okay. So we're going to put some variables here. We'll say that we'll put X as pizza, number of pizzas, or cost of pizza. We know what number of pizza. Cost for pizza. And we'll put Y as cost of the drink. Okay. So let's write an equation for Tony. Okay. So for Tony, he purchased 2 pizzas, 2 drinks, and it was $34. So that's going to be 2x. This represents for 2 of these 16-inch pizzas. Plus 2 drinks, right? 2y, and that's equal to $34. And then for the other person, Jody, right? She purchased 1 pizza, so 1x. She purchased 3 drinks, so 3y, and that cost her $34. Or sorry, $23. All right, number 2. We're going to use this. We're going to graph it. It says interpret what the point of intersection means for the 2 lines representing the equations. So we're going to have 2 lines that are graphed here. So essentially the solution for both of these equations or both these situations will show the cost for 1 pizza and 1 drink. Okay, now, and how do we graph this? Because we don't have a slope and we don't have a y-intercept. Now, if you remember from this, I'm going to write this, we can write it off to the side. We're going to figure out for this first one, what is the x and the y-intercept. So if you remember, the x-intercept, if we have something in slope, in standard form, to find the x-intercept, you take whatever c is and you divide it by b. So here, the x-axis, we're saying x represents cost of pizza. So we'll say, I'll just put pizza here. And y represents cost of the drink. We'll put drink here. Okay. So for Tony, this is all for Tony here. And I'll put Tony right here. So c divided by b. So c is 34, b is 2. So what's 34 divided by 2? The x-intercept, I'll actually write, we'll put 34 divided by 2. That is 17. So for Tony, you know what, I'll highlight him in, I think I put blue. So for Tony, I'll put that in blue. I'll graph his in blue as well. So where is 17 on the x-axis? 17 on the x-axis is right here. Okay, but let's also find the y-intercept. Now the y-intercept of an equation in standard form is c divided by a, right? So c the last number and a the first number. So c is 34, a is 2. So to find for the y-intercept for Tony, right, 34, it's exactly the same thing. It's also 17. So I'll put this in blue one more time. So on the y-axis, where is 17? It's right here. So to graph his, I want to connect both of these dots, and this gives me the equation of Tony. So this, I didn't need to complete a table like the previous lesson. But let's move on for Jody here. Okay, so Jody, we'll say for the x-intercept. Okay, this might go off the graph. The x-intercept here, right, it is c divided by b. Okay. C divided by b. Now hers, c is this, b is this. It's 23 divided by 3. Now 23 divided by 3 isn't a whole number, so let's do some scratch work here. Okay. 3 can go into 23, looks like 7 times, because that's 21. With a remainder of 2. We'll put decimals. I'll just put a 0 here. And 3 can go into 26 times, because that's 18. We can keep on going here, but for the x-intercept, at least for Jody, it's roughly 7.6. Okay, so let's put 7.6 right here. 7.6, so 7.6 is a little bit below 8. Something like that. Okay, and then the y-intercept, right, it is c divided by a. So hers is 23. 23 divided by 1. 23 divided by 1 is just 23. Okay, so we're going to have to estimate for this one. 23. So this is 16, 17, 18, 19, 20. Let's keep going here. Maybe this is 21, 22, 23. Okay, so we'll say that it's right here. Okay, let me connect both of these points here. We'll try to do our best to estimate. Okay, I see a point of intersection that's right here. It looks like we're going to be discussing that. Okay, this is the coordinate. Looks like we go from here. That is 3 and 14. All right, so $3 for something and 14 for something. So 3, we're going to say that this is $3 per drink and $14 per pizza. All right, so this is something we can use the information that we're given from two friends, and we can determine how much it is for each item at this pizza place. Okay. Anyways, we're gonna end our activity there. We're gonna skip talk to talk, and we're gonna go right to our lesson here. Looks like a lot of this is connected. We're gonna say for this assignment, we'll do everything on the front side, so numbers 1 through 5. Now, the table you're going to need to complete for number 6. 7. We'll skip 9. We'll do numbers 1 through 8 for this one. So 1 through 8. Okay. All right. When to there, let me know if you have any questions.